And we're live. Welcome everyone. This extra special change notice. I'm super excited. Joined here by Chris.
How are you
We're
guys?
gonna wait just a few minutes for everyone to file in. While we're hanging out here, we're gonna chat about the extra special Apple Studio, Mac Studio teardown. We're gonna talk Apple products just because everyone likes talking about their first Apple product. So question for those filing in here, please post in the comments. First off, introduce yourself. Make sure your Zoom chat is set to introduce to everyone, not just hosts and panelists. Introduce yourselves and tell us about the first Apple product that either that you experienced or the first one that you actually owned. Chris, how about you?
Yeah, well, I'm gonna date myself here, but the first Apple product I experienced was probably playing Oregon Trail on an Apple II or 2GS, something like that, in computer lab in elementary school. So that was, that was the first time I was like, wow, color screens, you can play a game. That was a lot of fun. But the first product that I owned was actually the iPod Nano, like when it was like the watch size, and I made it into a watch with one of those adapters. So that was a lot of fun. How about you, Tobias?
You were ahead of the time.
Yeah. I was like, I knew it was coming.
The Nano Watch. Looks like we've got some other Oregon Trail and Monopoly game fans. So my first experience that I remember, somewhat similar. It was in, I think it was a local library down in the basement. They had a computer lab, and they had what I believe was the eMac. It was the all-in-one with the different colors. It had the handle on top. I thought it was so cool at the time. And I remember someone had loaded on one of the computers, I don't remember the name of the game. It was a side scroller, and you ran up, it almost was like Donkey Kong-esque, but you were a little robber that was picking up bags of cash. That's what I remember. That was the first experience. First one I actually owned was one of the iPod Classics with the actual
the real scroll wheel. Nice.
Mechanical wheel.
Yeah. Okay.
All right. So yeah, welcome to those filing in now. Please introduce yourselves in the Zoom chat, and we're talking about the first Apple product that you experienced or the first one that you actually owned. I see we've got some MacBook, we've got iPod Nano.
We've also got some never Apples. Never will, never will.
Yeah, that's good. I like both sides here. So let's go ahead and get started. Welcome everyone to this extra special edition of Change Notice. For those just coming in, please introduce yourself in the chat in the lower right. Change Notice, what are we doing here? This is our monthly teardown series. We were just counting out, this is the 9th monthly teardown that we've done. We're super excited to take apart the Mac Studio today. So welcome back. We see a bunch of regulars in the crowd here, and welcome to those newcomers as well. Why are we doing this? Our goal here really is to build a community for sharing knowledge and to drive continuous improvement. So few housekeeping. Number one, if you do need to duck out early, please fill out that survey. That's how we improve this for next time. Number two, if you're an instrumental customer, look in your inbox. We're having a product roadmap webinar this Thursday, and you're going to be stuck with me for that one as well. So I'll see you guys there. And even more exciting, for the first time ever, we're having an in-person teardown. I know this is unheard of. In-person teardown in June. So please, I think in the survey there'll be a question about if you're interested in attending. More details to come on that in-person teardown. So without further ado, who do we have? Let's do some intros before we dive into the teardown. Chris?
Yeah, my name is Chris. I'm a product design or mechanical design engineer. I spent over 7 years at Amazon, working on a bunch of Kindle products, then bounced around to a couple of different companies, and now I'm working on autonomous self-driving electric tractors. So yeah, that's me. What about you, Tobias?
I like both ends of the spectrum there. So I'm Tobias. I spent about 6 years doing product design at Apple, mostly worked on iPhone and Apple Watch. So a little bit smaller devices than what we're tearing down today. So I'm excited to look at some of the differences. They have a little bit more space to work with here in the Mac Studio. I've been at Instrumental about 3 years now. So let's talk about why did we pick the Mac Studio here?
Yeah, I think the Mac Studio. So first of all, it's an Apple product, and I think everybody always is interested about Apple products. When I was at Amazon, whenever Apple would release something, we'd always rush to watch the iFixit teardown and see how they managed to manufacture everything. So I think that's one aspect of it. The other is just that there's something new. And I think this is like one of the most powerful computers in a very small package. And so I think we've heard a little bit about some thermal things that might be interesting to take a look at. But it's a beautiful machine, and it's something that any product designer would want to take a look at.
I think this might be the first product that we've torn down where I know for a fact that they intentionally made many design decisions for people like us that are tearing it down. There's an intense focus internally. So I'm excited just to see the cosmetics of the interior because they knew that people were going to be tearing it down. And
yeah, I was going to ask maybe the audience, maybe what do you want to see from this teardown? Maybe put a couple of questions in there, and we'll see if we can get to that in our as we open it up.
Great. Well, little sneak peek before we go in. We're going to look at, thanks to our friends over at iFixit and Creative Electron, we have an X-ray of the Mac Studio here. And so we've got both the top view and the side view, and we can get a little sneak peek. My immediate reaction here looking at the top is this almost quadcopter-esque shape that I can only assume is the thermal management system here, which looks pretty cool. So I'm super excited to see, like you mentioned, Chris, what they're doing with the thermals. Mm-hmm. And just looking at the amount of space from the side here, this thermal management system on the top half, it's just a huge portion. So a ton of effort must have gone into designing this thermal management system. So let's dive into it and see what we can find.
All right, let me share the screen here. And
looks like we have some agreement on the thermal management.
I agree. So why don't we take a quick look at this and then we'll just dive in right away. But you can see this is the Mac Studio. It's pretty small in this orientation, but when I turn it this way, you can see it is not small. It's thick, but it's small for what you get out of it, which is very impressive. So here's the bottom. You can see it just rests on this single foot, basically a little plastic ring here. You got a lot of ports in the back. I think this is designed for studio users, people who are heavy power users. So hopefully they'll be able to make use of all that power inside. You can see there's a lot of holes here. So for those that are interested in the manufacturing, this is definitely something to be interested in. There are a lot of drilled holes here and also on the bottom. And then you also get a couple of convenient ports on the front. So 2 USB-Cs and a regular SD card slot. So why don't I go ahead and get started? Since there are no visible fasteners, it's pretty obvious we have to open something up. So I think there is something under this ring. So this plastic foot, I think, comes off. So I've taken this apart before. So there's that ring, and you can see we have a couple of screws. I've already opened this up, and to save a little bit of time, we've already taken a couple of screws out. You might see them here, but I'm going to take a few more of these apart. So these are Torx, regular Torx, not the Pentalobe or the Tri-Wing that we've seen in other Apple products. And I think this is a T9. I'm getting a little bit of extra leverage here with this one.
We got some questions here, two good questions from Alex around the holes that you mentioned. Question one is, do we think they're for speakers? Or actually, first question was speaker or air vent. And I think we'll have to wait and confirm once we actually look inside. But what do you think, Chris?
Yeah, it's a good question. I mean, I think my hand's in the way. In this case, the sheer quantity of them, I don't think this one needs that much space for the speaker. So I'm going to go with the cooling system and thermal management. Yeah, what about you? What do you think?
Yeah, I think with the just looking at how much space they dedicated to the thermal system, my guess is that's going to be the primary use. And the second question here was around, we were just talking about this beforehand, how they actually manufactured that quantity of holes. Do we think Alex is speculating laser drilled potentially? I'd actually like to hear from the rest of the engineers in the audience. How do you think they manufactured that quantity of holes, especially on the bottom plate? It is not on a single plane, it's on a curved surface. And then even on the back of the device, it actually curves around the edges. How do you guys think that they made those holes? Were they, I know in the past I've seen some actual drilled holes. Sometimes they punch them out if it's a steel body, or laser drill as well. Anyone have guesses? What do you think, Chris?
I'm gonna say this is probably CNC'd, although laser drilling is interesting, just because these are at an angle and they're really large. I've had some experience with laser drilling holes, and those are, you can get the micro holes, and that's how like some of the old MacBooks and some of the other computers do it for the speakers. But to get this size of a hole, it's almost like a millimeter in diameter. I think you need to do a CNC operation. But that's me. We can always speculate on this. We don't know for sure since we didn't design it. So I've taken off. Oh, I need to do this. So it looks like there's a really big insulating patch here. So I'm guessing this is the power supply unit. There is no external power supply on this. Everything is contained in the box. So this can get pretty hot. Gets power from the wall directly. And it's insulated, but it's also got this very nice black colored cover here. So that's something unique, I think, to Apple. They kind of cover everything in black because they know that people like us are going to open it up and scrutinize every part of it. So
can you tell what that cover is made of there?
It looks like it's just a plastic. This is pretty flexible here. I'm bending it over. And it must be just an insulator because if we're right, this is the power supply board. There's a big metal component right beneath it, and that would be pretty bad to short right on the bottom side of that. Let me get this off. There you go.
Got a couple questions coming in from Alex. Is the silver bottom plate injection molded plastic? The silver bottom plate, I believe, is also aluminum, like the rest of the housing. Correct, Chris?
This is aluminum, but there is plastic around this edge because that's a different color, but it's seamless. So that's another thing that it's unique to Apple in terms of how seamless this is. There's no obvious gaps or anything. It looks like maybe it was machined together, and you can kind of see a little bit on the inside here. They do a good job of color matching, but this is kind of a plasticky gray, and this is the aluminum, anodized aluminum. So this is the power board. Maybe we can get a closer look in instrumental, just because it's kind of hard for me to hold this, so the resolution is not so great, and you can dive in. Also, we can take a closer look at that bottom plate.
Yeah, let's do it. If you want to stop sharing there. That is a hefty power board.
It is. And while you show stuff on the screen, I'm going to take some more stuff apart just so we can get through this a little faster.
Excellent. Yeah, we've got a ton of stuff to get through here. So buckle up. We're going to be going pretty fast to make sure we get to the thermal management system. So I'm showing here, I'm logged into our instrumental application. A lot of you guys have seen this before, but for the newcomers, quick recap of what our platform does here. We're a manufacturing optimization platform, and we help to find and fix issues on your manufacturing line. So we're helping out engineers just like you guys, a lot of times in NPI, making sure that you guys can hit those build schedules and ship a product on time. In MP as well, resolving issues quickly, obviously to keep yields high. So today we're mostly just using it as an image viewing platform. So we've just got images of the entire teardown here. And later we can talk about how you guys can get access to these. So I know there was one question around where these holes normal to the face. So you can see here, it's a pretty impressive hole pattern. It does look like all of these holes are normal to the face. And assuming that these were CNC'd with a 5-axis, all I can say is, wow, that's got to be a pricey operation. I think, Chris, you estimated the number of holes. Does anyone want to guess?
Oh yeah, please guess.
Over, under. Anyone want to guess the number of holes on this bottom plate here? Because this is just insane. I don't think any other manufacturer would do this. We've got a 200. We got all ends of the spectrum. We've got 200. We've got 10,000, 400, 800. Let's see. The winner, Chris. What are we looking at?
Yeah, it was more than 1,500. I think if I counted right, I got 1,696 thereabout. So almost 1,700 holes just on the bottom plate.
1,700. So,
yeah, I'm just imagining going back to like the machine shop days and like drill one hole at a time. You gotta bring the tool down, and then this is at an angle, so you got to rotate your part every time you do that. It's crazy. Hey, what are those? Those look like little marks there as well on the upper corner that you're looking at.
Yeah, this is really interesting. I'm curious from the audience as well. Have you guys seen this type of mark? Again, this was under the pad here. Alex thinks it looks like Braille. That was my initial reaction too. I was like, wow, great. They've designed this for blind people.
The teardown for blind people, so you can identify. You're now taking apart the bottom cover.
I think so. I think Steven's got a good guess here that it's a date code, which is really interesting. I've seen a lot of these on other devices that we've torn down. In particular on plastic molded devices, they'll have the machine, the tool, the lot, the date. Typically, it's just a numerical or alphanumeric. So this clearly they've come up with their own code here to designate what I can only guess is the date code or lot code or machine. And what's also two more things before we keep going here. One, Chris, you had mentioned this plastic rim. So we have the aluminum bottom, the plastic rim. Would like to hear from the audience here before we go inside to answer what do you think the purpose is of this plastic rim? They have such a nice aluminum body everywhere else, and then they have this one plastic rim.
Yeah. Also, you can see, I think someone else asked earlier about how do they manufacture that to get it so seamless. And we were talking about this earlier. I think our suspicion is that they actually insert mold like a block of aluminum. And maybe before they cut all those holes in it, just so that if they cut all holes and then damage the part when they do the insert molding, they don't actually have to throw the whole part away. And then they probably machine it or polish it afterwards so they can get a very seamless, it's like so smooth, it's as if it was one part. So I think that's how they do it.
It's pretty impressive. The other thing that I noticed here, we've got this typical design by Apple in California, but made in Malaysia, which is a new one. What do you think? What do you think about that one, Chris? Have you seen that before?
I haven't seen too many like whole computer systems made in Malaysia. I suspect this is Apple's response to those tariffs that were put in place and that have not been repealed. I think by the Trump administration, because they're taxing or adding tariffs to a lot of consumer products and metal products that are made in China. So if you make it in Malaysia, you don't have to suffer that, and it's like a 20% tax. So they're doing that. Doesn't necessarily mean all these parts are made in Malaysia, but this was probably assembled in Malaysia, which is interesting. And we're seeing things maybe move away from China as the dominant or the only manufacturing place for these things.
Yeah, I think that's a really good guess. Would be good to hear from the audience as well. For those of you that are working in manufacturing, have you guys either had to move manufacturing facilities, either because of tariffs or a lot of the supply chain issues as well? We've seen a lot of manufacturers moving outside of China to the greater Asia. It would be great to know what everyone else has seen here. So before, let's hop to the power board that Chris showed here, which is, wow, this is just a hefty, jam-packed with very large components power board. Still fairly visually pleasing with most of the stuff black here. Looks like we've got a couple large heat sinks that are sticking up pretty far, and a bunch of globs of, yes, black glue to make sure it blends in, which is really interesting. There's a couple things that this glue could be doing. Chris, do you have any thoughts?
We looked at something like this on the Sonos board, and for them we thought it was maybe like vibration and dampening kind of controls, but this computer doesn't have such a large speaker, so maybe this is more for insulation purposes or something like that. I don't know. What do you think?
We've got a couple responses, maybe about thermal flex or the coil damping. Could be those. I have also heard as well. I think it can be multiple purposes. One is actually structural, because again, there's very high voltage. There's 120 volts coming straight into here. I think it might also play a role, like you said, in the electrical isolation. This is typically like an RTV kind of just globbed on there. And yep, if components are too close together with that super high voltage, there can be arcing. I actually remember one of our customers, actually, it was a consumer electronics speaker, I believe it actually was, that was having ESD issues. It wasn't the same 120 volts, but this RTV, this type of coating that you dispense, this is mostly manual. It's a super sloppy process. You can see here, and it's pretty hard to tell when you miss one of these because there's no functional test. So they had some reliability failures where like 10% of the devices were failing this ESD test. And one of the chips was getting zapped, and they were spending all this time doing the failure analysis, and they went back into instrumental and went back and looked at those 10 devices. And it was pretty immediate at that point that the root cause was they had missed one little bead of glue. It had like shifted over. Probably the operator was a little bit tired that day. But again, glues, they're always messy. They're hard to control. Let's see. So, and on the back side, I know someone had asked about what we have on the shield here. I think this was just, someone had asked like what this was made of. I think you said this was just plastic here, right?
Yes, I think this is just plastic, just to cover that. But I can do another check and confirm. Yep, I think it's just plastic.
Perfect.
Yep.
This one more thing that it's a great comparison here. You were talking about, Chris, the The
Yeah,
Sonos, I think we had a Sonos with,
it's the Sonos. They had power coming directly into it, I think. So
yeah, so let me hop over here. And for anyone interested, we have the whole Teardown library. There's a lot of great images here.
yeah.
So if anyone's interested in getting access to this Teardown library, let us know. I think in the survey afterwards. And I know some people that'll hook you up. Let's look at, I think it was right here. Yeah.
There it is. Yeah.
So similar, not quite the black RTV, but likely similar functional application here. Maybe with the added kind of anti-rattling, since this one was a speaker.
Yeah. Yeah. But I think this answers some of those questions that we had talked about before at that time of, is it just for rattling, or maybe there is also some functional requirements, just because if those capacitors get too close to one another, maybe that's a risk for shorting, and you don't want to short 120 volts into your expensive speaker or more expensive computer.
All right, we got a lot of stuff to get through, so let's hand it back to Chris. And again, for those in the audience, if you see something you want us to dive into a little bit further, let us know.
All right, so I have spent a little bit of time. You can see the number of screws has grown over here. So I took this kind of frame off, and this frame is made from aluminum on the outside, but then there's this plastic coated, but I think it's like sandwiched. I'm not sure if you can see that. There's a little bit of I think there's like maybe a metal plate or something in there that gives it some stiffness. But this frame, I think it has like where the Kensington lock comes in that secures the computer to the ground or to a desk, and also is what holds the foot and everything together. So I took that part off. I've also started to take some of these like connector stiffeners off. So there's a lot of different screws here, but I'll show a couple of different angles here. So you can see this is where the USB-Cs are. This is the Ethernet port, the main power, and a couple of the other connectors. This is the speaker I've started to take off. And you do have to take these all off in order to get access to take this board out. What's nice is that they're all modular. So if there's any iFixit fans or iFixit people out there, I'm sure you guys are happy that these ports are all replaceable. But it is kind of annoying and a pain in the butt to take them all out, just because you have to do them all one by one. And so I have like 6 different Torx screwdrivers here just to see if I can get some things out. There was one interesting point here, which I have to remove this screw as well. Or not a screw. Is this the right one? I thought this was the right one. Nope, I need a bigger one. Is that these are standoffs, but they have a Torx standoff. So that's what the speaker was resting on. Oops, I need another one. Maybe.
Chris, can you tell, we had a question from Gustavo about what kind of speaker that is. Is there any indication on the back? I saw some text there.
There's not much. It's just a serial number. It looks like it honestly is like a pretty small speaker. I mean, it's in a sealed enclosure, so they've done their best to get this to be really as good a performance as you can get out of this size speaker. But I don't think you're buying this computer for the speaker. This is not a Sonos. You can plug in some really awesome speakers while you're getting your 6 streams of video and music or whatever in to one of the USB-C ports or the audio jack. Let's see. So I'll take off a few more. Actually,
I'm noticing all the screws that you have there.
Yeah.
Yes, surprisingly so far, this seems to be pretty easy to take apart with just screws. There's no glue that would be unrepairable. Is that right, Chris?
That's correct so far, except for the only real tape that we encountered so far was in the foot, just to get into this. So here is, I gotta take this connector off. Here's the Ethernet connector. So really interesting that they have like a little bit of conductive fabric actually on the rim of this, and that touches off on the board there, or on the main aluminum housing. And then I've got a number of different USB-C ports here. I'm going to try to unscrew this large stiffener. But yeah, in the meantime, you can see, it's definitely designed to be taken apart and gawked over because it's all black inside. Everything is neatly arranged. Even some of these screws are like all black. Like these are really shiny, that's unnecessary. When you're making these things, you don't need to make the screws black and shiny, because that's a little bit harder of a process to make.
They do look pretty nice though. So Colin had a question about how the cables, the FPCs are being retained. I think Colin let us know. I think you're referring to these USB-C connectors up at the 90 degrees here, how those fluxes are being retained. Chris, can you describe the cowling that you have there?
Yeah, there's like a little metal stiffener which has looks like a raised section that makes it stiffer across. So they've got a little bit of height in there to make the cross-section area bigger. And then they've screwed it down on both ends of it. And then these are pretty beefy connectors. So you got 2 USB-Cs on each, and I'll just take one of them out here. I've already taken out some of the screws for this, but you'll be able to see what they look like in a second. But yeah, these are very impressive looking, and each one is sort of individually screwed in. And why do you think that is, Tobias? Why not just put them all on one big board all the way across? Here's the USB-Cs.
Oh yeah, when we dive in to look a little bit closer, it almost looks like so those USB-Cs don't actually have a frame on the outside to guide it in. Is that right?
You're right. Yeah, these are just the tongue of the USB-C port. So they're probably using the housing from the aluminum as what usually has like a stainless steel rim around the outside to support your connector.
So I would imagine that would be pretty difficult to get the spacing consistent with just SMT tolerances there. If you had it all on one board and you needed to align 4 USB-C connectors to the housing, that would probably be a pretty sloppy tolerance loop there. So yes, that would be my guess about why they have those separate fluxes.
I think you must be right with that. That's something I hadn't really considered. Especially now that they have so many ports on this, they probably want to make sure that those all come out and look perfect in there, especially if they don't have those little rims around the outside.
Yep. A few questions I want to get to here.
Yep.
It looks like Ron's on the same page as us here. Modularized the IO for better fit and finish for the alignment there. Kieran's asking about the undercut inside of the aluminum wall where the connectors live. I believe that is an undercut, right, Chris?
They are. There's this whole rim is actually an undercut. I think one of the big questions about this type of device, or a lot of the Apple devices, is how do they manufacture this, right? So what is the method of manufacturing for this giant aluminum block? And what do you think, Tobias? Is this a is this forged? Is it cast? Is it machined? How do they do this?
I would like to think that there's a way that didn't involve so much waste as just milling it out. But typically, from what I've seen, the most tried and true reliable method is just to take a big block of aluminum and just a very large amount of machining time down from the top to get those undercuts. Again, they're probably, recycling the extra aluminum here, but I think they probably went to the extra expense. Again, considering where this product lives, it's not a crazy high volume, and it is a higher cost product. So they do have a little bit more margin to spend, but wow, I can't imagine that insane amount of machining time just to hog out this giant aluminum block.
Yeah, I think you're right. This is totally machined. There's no real other way to do that. We had at Amazon, we had looked at before at doing like a forging process. So you can get like near net shape and then cut things out. And I was thinking they might have done that. But one of the challenges when you do that is you pound like the corners in and you get a denser bit of aluminum in those corners. And then when you anodize it, you start to see a little remnant of that anodization of that like denser area, which obviously wouldn't fly with the industrial design people here. If they want everything to be black, they want everything on the outside to be uniform. So I'm sure this is machined. Yeah, completely.
So we had a few questions around
the
different electrical components, the X in the middle. Well, I think you've still got a few connectors to take off there. I'm going to hop into the close-up and see what we can find. It's pretty, again, all black everything, visually pleasing. You can be sure that the ID team has reviewed just about every component that you can see here. And before we dive in, actually on our glues versus screws, we got to give a shout out to our iFixit guys. And we're actually bringing back manufacturing jokes, one per hour. So if you want more, you've got to upvote and request them. So as a tribute to our iFixit, what did the iFixit repair specialist say when they saw the new glue gun on the line? Oh man, screw this. Repairability jokes. That's a shout out for iFixit there. I'll vote the jokes if you want we've got a dedicated joke writing team. I can't take credit for that one. So back to the real stuff here. If you take a look, question about what this very nice looking X is in the middle. I believe that this is the CPU is housed under here. It looks like a little heat sink. Can you tell what this is, Chris?
It looks like it's a big spring, honestly, and it holds. So there's like these 4 big screws that hold it down. So I think you're right. This must be where the CPU lives. Although it would be interesting to take that off and also to take this whole thing out, because that's got to connect to that big fan system we saw in the in the X-ray. So that could be the chip, or it could be maybe it's the back side of the chip and it just needs a lot more cooling. So we'll see. We have to open it up.
We'll have to wait and see.
Yep.
All right, quick tour of what else we can find. I know someone was asking about what was unique, what the lay of the land was for components. So I believe we have the memory, the hard drive down here. Like we've got antenna cables coming in. There's probably the antenna chip here. It looks like these are antenna modules placed around the outside of the housing. Looks like we have 1, 2, 3. And that could actually explain, coming back to the beginning, about what that small plastic rim was on the back. I know there was some speculation around electric isolation. I think it might actually be for antenna RF permeability.
I think you're right. Apple has done a lot, especially with like iPhones and others, to use the metal frame as sort of the ground, and then just have small escape paths for the RF signals, and that a little bit of plastic around the outside might be just enough. And because it sits off the ground, you know, like the foot is raised by maybe like I don't know, a third of an inch, a half an inch, that should be just enough to get the antennas out. And you know, like they probably have these antennas in different locations, so depending on how you stack it on your desk, you can still access your, you know, Bluetooth peripherals or get good connection to the device. But yeah.
Yeah, we have some interesting questions around what the antenna modules look like and how they're actually connected.
Yeah.
So if we can jump here. I don't know if you're able to take one out, Chris. I think I have an image.
Yeah, why don't you start with the image and then I'll see if I can.
So this is the antenna module. You can see the side here. So it looks like there's actually the active element on top, which is a flux connected to the coax. And then there's this interesting shield can down here at the bottom. I've seen a few designs like this in the past, and I believe it's around, this is like a controlled, almost like resonant amplification chamber. What do you think, Chris?
Yeah, I think that looks about right. It seems like because the whole other part is like grounded metal, they probably wanted to control precisely how much this antenna is resonating. And so, yeah, I think you're right. That makes a lot of sense to have a contained unit. And because they have so much vertical and XY space in this product, unlike, you know, some of the phones and other small devices that we've worked on, they probably had plenty of room to just stick those in the corner and make them as deep as they can, or as they need, not as they can.
Yeah, so I think that's the antenna module. You can see here the coax connectors. These are always tricky. I have a personal experience as well as with some of my customers on the routing, both making sure that they're consistently clipped in, as well as the routing of that cable can have a tangible impact on the antenna performance. I see this screw here. This is a pretty hefty retaining device. Normally I just see the clips, and that makes me think they really wanted this connector not to pop off. I know one of our customers actually found through instrumental, they were having antenna. It was actually like a population that was drifting and failing their antenna test, and they were able to correlate it with instrumental to a 20-degree rotation of the coax exit here. So you better believe that these routings here, these are all intentionally controlled. They might even have pre-bends on some of these coax cables.
Yeah, if you scroll down a little bit on this image, you can see they also have these little grounding points that are kind of on the left in that one. So this is like another antenna here. I remember we looked at the Nintendo Switch, and they had a really long cable without any grounding points for their Wi-Fi antenna. But this one, you know, Apple must care a lot more about how grounded this antenna is, because they have two of those ground points there soldered on or attached somehow to the edge of the main housing. So that's kind of interesting to see how they added those clips.
What do you think, Chris? So again, I see a few connectors here. It looks like maybe a ZIF connector underneath some tape.
Yeah,
we've got a ZIF connector on this IO board over here.
Yeah.
ZIF connector looking around. What do you think this tape is? Tell me what you're seeing on top of the ZIF.
Honestly, it just looks like it's used to kind of pull up these. That must be where the fans connect. So I think they're just used either to pull up the connector or to maybe hold it down, so like in a drop event somehow it doesn't pop out. This kind of reminds me, or maybe as a contrast, to that HP reverb that we did, where they had you know, they didn't have the black tape over it, so you could kind of see if the connector was in place. And I know that's one of the things that I think Instrumental is really great at, is identifying when your flexes aren't in. So if we can take a look at that, maybe we can compare and contrast how those look.
That's right. Yeah, this was a very different, just visually jumping over from the Mac Studio to this. A lot more color going on here. No black PCBs, but the design choices around the connectors here, I remember being really impressed by, because you can see here on these, I think these were speaker connectors. I think they actually had a small little hole on top to verify that those connectors are fully inserted. On the ZIF connectors here, you can see both the alignment line to make sure it's straight, as well as the tab for easier insertion. So they definitely had a very intense focus on kind of ease of assembly, where it looks like Apple might have actually made a few compromises there for cosmetics. And I know ZIFs personally are very tricky to get fully inserted and to make sure that they're not tilted at any angle.
Yeah.
That's why I always suggest including this alignment line, because it's pretty low cost to add in, and it makes it easier both the manual inspection to tell when something's off, but also with Instrumental. We have I think at least 3 different customers that have added in these lines, because it makes it super easy for Instrumental to tell, even if there's just a slight tilt on these connectors, you can catch it before it. The consequence was, connectors were popping out during drop tests. That's the worst case.
Yeah. I think that's really good to know. And if, not everyone can have the ID team sort of dictate everything that goes on the board. And if you want something that's a little bit easier for manufacturing, I think that's a really good way to go. But you don't get this beautiful black product that needs to be taken apart. And yeah.
All right, I want to make sure we want to get to the thermal unit. I know we had multiple requests to see what's going on with the thermals here. I'll switch it back to you, Chris. We're able to get the giant module out of here.
I am just about to, so I'll show that, but I think I have taken everything else out. So you can see my area here is getting a lot more populated, but I think if I drop this down, there's like a little undercut. There we go. All right. And this one is coming with it. There we go. So that's the main housing. It's pretty deep. It's like 3.5 inches deep. So that's a way to hog it out. That's you gotta hog that out. The other thing you can actually see now that I've got this out, these holes actually wrap around the corner, so they're not just all straight, which is mind-boggling. And so here is the back of the unit that we were looking at earlier, and here is the top side. So this is 2 giant fans and a huge metal heat sink here. So this is, I think, someone's question earlier was, can this device sustain the performance of the M1 chip, or is it just sort of, has to throttle back? And I think Apple has designed this because this is very front heavy. Like this metal section is huge. I think this can probably sustain that performance for a long time.
That could lead to one other question here. I think it was from Alex. He was commenting on, it looks like there's a decent amount of empty space on the PCB. How could that be? Shouldn't they maximize everything within such a well laid out product? I have a few thoughts on what actually could be driving the design. If anyone else in the audience has thoughts as well, as why is there actual empty space on the PCB here? What do you think, Chris? Any ideas?
They might have designed this around how much space they needed for thermals, and not so much what they need for the board. Because yeah, you're right. There's a lot of empty space here. The other is I've heard. I think we have the M1 Max chip here. The M1 Ultra chip, I think, is like double the size of the M1 Max chip. So if they wanted a common layout, they might have needed to accommodate that one first before switching over and designing for this one. So those are the two thoughts I have. What about you?
Yeah, my best guess is likely the size was defined by the thermal management. Just looking at how much space and how much thought went into that, that seems to be central to defining the full system. And so I think that probably defined both the X, Y, and likely the Z of the product as well. And that allowed them a little more space on the PCB.
Yep, I think that makes sense. Gotta find the right screwdriver here. Here's T8. Oh, what should I take up next? You want me to take off this this part, or I guess I can try to take off the whole board and see if we can see the other side of it.
Yeah, why don't we jump to, we can jump back into instrumental as you take off. Let's look at that thermal unit on the back, because that thing is massive.
Yeah.
And we can jump and see if we look. So you've got this part out here.
Mm-hmm.
So what we're looking at, again, it's this entire assembly of the main PCB, and what we're calling this thermal assembly. And I think, Chris, so I think you can take off, there's these fans that look like they're blowing over this heat sink here. And if you're able to pop that off, we'll skip ahead on the bottom.
Oh yeah.
Again, this is the top here. Once you take off this spring, which is a pretty interesting design, we can talk about that in a minute.
Yep.
On the back side, this is what looks like where the CPU actually is. So that's actually interesting. This heat sink on the top side, it almost looks like this is just an auxiliary cooling in addition to this very large thermal management system.
Yep.
In the back.
Yeah. And I think this might be the outline of what the M1 Ultra actually is. So if you had a bigger, if you had the maxed out version of this, the ultra out version, then that might be where the chip goes. And you can see there wouldn't be that much room to fit in that much other stuff if that was true.
Yeah, another good point on the PCB layout is around the multiple SKUs they have. So then this is where it gets really interesting with the thermals. So it looks like they have thermal paste here, which that's a whole different topic about controlling thermal paste.
Yep.
And then on the flip side, so this is what Chris is taking off here, is what looks like, this is a really complex thermal assembly here. Looks like maybe in the center, there's a copper plate.
Yep.
And then it's surrounded by the structural aluminum frame. And then if you flip it over, again, this is where the fins are, and this is where the fan was just taken off. It looks like there may be, what do you think, Chris? Some type of thermal transfer directly from this copper. And then there's these two pipes here that go into the fins. Looks like Alex is guessing heat pipes. What do you think, Chris?
I think Alex is right. Those look like heat pipes, which reminds me of the switch that we took apart. They had heat pipes, but they weren't black. And
oh yeah.
And I was, I always thought those are just kind of copper, just like a direct transfer of copper heat. But I think we learned the other day that there's actually like a fluid inside that heats up as it gets hot, and then it vaporizes, and then it kind of goes towards the cooler section, and then it cools and becomes a liquid again, and then flows back to the hot side. So very efficient for thermal purposes here. But you can see the difference here where they just kind of bonded it on, left it copper on the outside versus Apple's all black. design.
Yeah, I thought that was really interesting. And would be great to hear if other people have experience with these type of heat pipes, because it's a pretty impressive, I think it's a pretty common design from a few manufacturers that deal with these heat pipes. But yeah, I always also assumed that it was just copper was a great heat conductor, and that was transferring the heat from the CPU over to the fan. But I believe you can see here it is actually pinched off at the end because it's containing a special heat transfer fluid inside.
Learn something new.
So let's go back. Let's go back here. And so it looks, let me see here. So we got the fan here. And I know someone was talking about Tim.
Is that an antenna? Is that the antenna cable that goes all the way across and it's like screwed down?
It does. This is the same antenna cable that has, it looks like 7 or 8 actual screwed down antenna clips. Okay, this is a very intense cable routing. And so looking back, where did that come from? That came from, if we look at the PCB, is that this cable here that came all the way from that side underneath and up to this antenna here?
Yep, I think so. And that's probably why it's also screwed in on the other side, just because they were making those, and probably hard to route that around unless you screw it down first and then snug it in.
Yeah, again, intuition might say it'd be super easy to just route this right over the top here with some clips, which probably would have been the more efficient design. But what do you want to bet, Chris, that this decision was made by ID because they wanted to keep the aesthetic without a cable crossing there?
Yeah, I think that's right. And, it does make it look nicer. It looks like there's nothing else in here. So, props to Apple for figuring that how to please ID.
Yeah, impressive. All right, we've got just a few minutes. We got 5 minutes left here. So if you have any other questions, please post them in now. You can also, I believe Zoom has this feature here. You can raise your hand and you can come up and join Chris and I to ask a question live here. So feel free to do that, or post your questions in the chat. A few last things that we could talk about. We could dive more into the housing. We can talk a little bit more about some of the IO connectors. We've got some close-ups there, or we can continue to talk about the thermal management. So any final questions? Looks like question on what method was used to bond the plastic and aluminum. From Chioni, just to confirm, are you referring to the plastic on the bottom cover here and the aluminum, or was there a different part that you were looking at?
Yeah, I think it's that one. Why don't we go ahead and guess it's that one? Nope, yeah. I said yes. So yeah, I think our suspicion is that this whole piece is machined, and then they insert molded that plastic. And you can actually see here the parts that have this conductive foam around the outside must be metal, because they're trying to conduct outside between the two aluminum housings. And you can see here that it's raised and lowered, and then there's some gentle curves around, which is a very good indication of machining. And then they probably insert molded that. So they took that whole block of aluminum and put it into a molding machine, injection molded the plastic around it. And then because it's so smooth on both sides, they probably did a secondary machining process to trim that down and to polish that. So if you actually remember those little machine marks that we saw, the machine number marks, there are different ones in the front and the back of this, which indicates that there are multiple types of machines or multiple types of multiple steps to to this machining process. So it's not all done at once.
Yeah, this was pretty impressive. The machining process overall here is crazy how much time this must have taken. But yeah, you can see here the inside. There were some questions as well around the type of anodization that they're using here. I know I can say for a fact that Apple has a very large materials team that's focused specifically on developing not only their own actual alloys of aluminum, but the coatings as well. I believe it's a custom developed recipe. Typically I know a lot of times they'll sandblast it to get the texture beforehand, make sure everything's uniform, and then do the anodization afterwards. I know on the watch, the anodized aluminum, a big part of it was getting the corrosion resistance, which probably wasn't as big of a factor here, but I can say they spent a lot of time getting that perfect recipe.
I think someone had mentioned that there might be some kind of deep draw or something like that, and that's possible that they might have drawn some of this for like the foot, but there is some minimum thickness that they would have had to machine out. So it's still, instead of maybe a 3/4 inch plate, maybe it was like a 1/4 inch or a 3/8 inch plate that they still bent down or slammed into forged into a near net shape and then machined off. But yeah, it's kind of crazy what Apple does just to get some of these things. Not every company can take the time and spend the money to do this, but with Apple's manufacturing prowess and their operations teams, they're able to recollect all of that and recycle all the aluminum, and probably make it into new iPods and iPhones and devices.
All right, I think that is a perfect time to wrap up here. If anyone wants to stick around longer, we can poke around with some of the modules here. So a few reminders. Again, for anyone interested in what Instrumental can do to help out on products, we can take in image data as well as all your other functional test data. And we've actually got some new capabilities that allow us to deploy super quick. We've actually done as fast as 1 week when engineering teams are in dire need of data from their line. So that's what we do. We're here to help out. If you've got an upcoming build for your product, let us know. We can help. That's what we're here to do. If you want access to all of these images in our Teardown library, or you want a little further demonstration of what our platform is actually capable of, reach out, communications@instrumental.com. And that survey, that's going to be key. That's going to decide what we actually tear down next. So we have a teardown coming in May, but it's going to be decided by all of you guys. I think we can post the registration link for that teardown. So you can sign up now, but really we have no idea what we're going to tear down next. We're just going to look at all of your comments and pick whatever the most requested one.
Yep.
And then again, stay tuned for the live in-person event that we're doing in June. So thank you everyone for coming. Great questions. Love the discussion. We'll see you next time.
Take care, guys.
Manufacturing is changing, and keeping programs agile and on schedule is harder than ever. Leading engineering teams rely on Instrumental to find issues earlier, fix them faster, and make sure they don't come back. Experience the first manufacturing optimization platform designed to enable continuous improvement of your process, from development through production, by unifying your data so your teams can make decisions faster. Instrumental makes finding correlations in product data easy, so your engineers can spend less time wrangling data across email, spreadsheets, and internal systems, and more time solving problems. It's simple. We put the right data in front of the right people in real time. Instrumental aggregates images of every unit at key assembly stages, parametric test data, and measurements in real time in a secure, managed cloud. When installed across factories in a supply chain, brands and suppliers are able to work together to solve their most complex issues. From your first build, Instrumental's Discover AI proactively identifies new issues by scanning your products for anomalies and automatically delivering a daily queue of issues. Engineers can jumpstart failure analysis with defects in context. Engineers leverage a rich, remote dataset to quickly identify correlations and potential root causes, and can push live tests to validate solutions immediately. They use Instrumental to eliminate issues at the source and make sure they don't come back. With complete build and issue analytics for the entire team, program leads can kickstart daily stand-ups, streamline executive reporting, and communicate seamlessly with global teams. Instrumental has helped leading engineering and operations teams move faster, improve yield, and build better products from proto through production. Better products start with better data. Better products start with Instrumental. Schedule a demo today